Hello everyone, Professor Dustin here, and this video is going to be about scientific writing. This is basically going to come from a publication put out by the Nature Journal about writing for English communication for scientists. So they cover a lot of different things, including like presentations and other kinds of talks to the public, informal communication, but they also talk about journal writing. As well, I'll put a link in the below this video, but this is going to be the structure of a scientific journal article from Nature. Nature is one of the most highly regarded multidisciplinary journals out there. I mean, it's been around for 150 years. It has subfields, so there's a nature physics, nature geology, all these subfields, but there's also the main Nature, which is highly regarded among the entire scientific community, which is why I like the article they put out about how to write in science, because it is useful for all the scientific disciplines, including physics. So what I'm going to tell you is sort of a summary of that, and you can read more about it in the link below the video if you want to check it out. So the first thing we should acknowledge is scientific writing is not like other kinds of writing. In other kinds of writing, you want to get across a particular message, such as like you want to describe something, or you're trying to evoke some kind of emotion, or you want to communicate some kind of description of something to further a storyline. But in science, we care about clarity and detail over eloquence and sentence structure. So that doesn't mean that we can throw out the rules of English grammar, of course. We need our writing to be grammatically correct, but we don't need to say things perfectly. We don't need to say things with exactly the ideal sentence structure. All we need to do is be clear about what we're saying and provide enough detail so that the people that we're talking to or writing to can understand what we're saying. So when we're writing in science, we essentially want to communicate three basic things, usually summarized as why, what, and how. In a little bit more detail, why was the work done? What was the result? And how was it done? So this is generally the pattern or the content you want for every scientific piece of writing, whether it's something for like a peer-reviewed journal or something for this class. And indeed, we should think of our articles that you're writing as articles for peer-reviewed journals. Okay, you're submitting them to me, I'm going to be the peer reviewer, but we want that attitude. You want to present in as clear and detailed way as possible what you did, why you did it, and how it was done, so that in principle somebody else could repeat the study and also demonstrate to me that you understand why the study was important. So to this end, I'm going to present to you the structure of the lab reports that we're going to use. Indeed, this structure comes right from the Nature Education publication. So it's not just the structure for lab reports, it's actually a good structure for nearly every piece of scientific writing, but it is the way that we're going to structure our lab reports. So we're essentially going to have four different sections for our lab reports. The abstract, the introduction, the body, and the conclusion. And I'm going to go through each of them in turn to give you an idea of what they're all about. So the abstract is essentially a short overview of the study and the results. It's the first key section of any article. So the abstract must be able to stand on its own. It has to be complete. It can't be you're missing a key piece or you're missing a key result. It has to be readable and give the reader the impression of what the study is about, why you did it, and also what the important results are. It's what people are going to read to decide if they should continue to read the entire paper. Obviously, to do that, you can't talk about everything. Abstracts are typically like one paragraph long, so you typically have to drop some stuff. Typically, you drop the how of the article, and instead focus on the motivation and the outcome. Of course, you only have a few sentences to do this, but that's typically what it takes. One or two sentences on motivation, one or two sentences on outcome, and that should basically consist of the abstract. After the abstract comes the introduction to the paper. The introduction should include all the background required to understand what's going on in the paper, and also just briefly how you actually did the work. You want somebody to read the introduction, understand the motivation and why you decided to do this project, and also briefly the equipment and the approaches or analysis that you use. You're going to have other sections to talk in detail about that stuff, but you just want to give people a quick idea about roughly how you did it. So this introduction section can actually be quite lengthy and quite tricky to write. So actually, there's sort of a shortcut for writing introductions, and that's breaking it into 4 essential paragraphs. Now, this doesn't have to literally be 4 paragraphs. Maybe it's going to be 8 paragraphs. Maybe it will be 2 if you can combine them in some way. But you can think of 4 basic short sections to the introduction. And those four short sections can be described as context, need, task, and object. So context is the background. What background information does somebody need to understand what you're doing? Typically, this is just the minimum that is needed to understand the project. Now, this is a little bit tricky because you need to know your audience and you need to know what the typical reader will understand, and so we'll talk a little bit more about that. But generally, you just want the minimum needed to understand the study that you're doing. And often you start with talking about broadly why the project is interesting, like in the entire field of physics, let's say, and then you narrow down your focus to say, like, here's a subfield of physics where this is interesting, and in that subfield, here's this aspect of that subfield where it's interesting, to give people a contextual idea where it sits in the entire field, specifically in our field in physics. So once you get into saying the background that people need, now we can move on to the need of the study, which is really the why of the study. Why this particular thing? So given that we sort of understand the background needed to understand the study, why have you chosen to do this specific thing? Why this experiment? Why this particular measurement? Why are you studying this specific effect? And that should follow from the context. There should be a natural transition from the context, the background, to the need. At this moment, this particular thing is needed to be done. So the task is the what. What have you done to address this need? So you're going to have another section where you can put in detail what you have done. So you don't only want one paragraph or so about this, but what specific experiments or analysis you're going to do to address the need that you talked about in the last paragraph. The last section is the object. That's a literal description of what is in this document. It might be, we're going to start with this introduction, and then in section 2, we're going to do this. Section 3, we're going to do this. It's a very clear way to say to the reader where they can find things in this document and what each piece of this document is going to be. It is sometimes the exact same for every single study. I'm going to give you some examples of introduction, and you're going to see the object kind of writes itself. All you say is what each section is, but it's a guidance to the reader, something like a table of contents, but for a shorter document. That is, table of contents is not really needed. Actually, for long scientific papers, they may include a table of contents, and then that takes care of the object. But if there isn't a table of contents, you need a paragraph that says what each section of the journal article is going to be about. And that's the introduction. So this is sometimes the hardest to write. It is sometimes the most lengthy to write, but it typically can be broken into these 4 paragraphs or 4 sections at least to help you guide your way through it. So write the first, context, then write the need, go to the task, and then finally finish with the object. So the next section of the paper is the body. So the body includes all the details of how the study is done and what the results were. So just notice the keyword detail. So now we're starting to get into the detail of specifically what this study was about. In the introduction, we talked about why we're doing it, and now we're going to go very detailed about what the study was and what the results actually were. So this section is often skipped by non-experts who are reading the paper. If I want to read about COVID, right, I read the introduction so I know how they did the work. I skip the body because I don't understand anything about how the mechanics, the biomechanics of how COVID works, and then I read the end, the conclusion, right? So you can be as detailed as you want essentially in the body. I will help you, give you some guidance over what I'm looking for, but essentially you can give as much detail as you like on how you did the study and what the results were. It is often split into, this is very dependent on what kind of study it is, but it's very often split into 2 separate sections, the methods and the results. And so obviously that's split into the 2 sections included up here, how the study was done and what the results were. A few things that go in the methods section: what was done. You can talk about what problems came up and how you solved those problems. And definitely in this section, you want a presentation of the data that you took. And so that might take the form of tables or graphs. Now, sometimes graphs are part of results. Sometimes graphs are part of the data itself. That's kind of up to you. But definitely you want to present what you did, the raw data, in the methods section. And sometimes this is also experimental apparatus. So pictures of the instruments you used, whatever. So that kind of stuff goes in the methods section. The results are pretty straightforward. Usually, what did you get from the data? You might want to talk about the analysis that you did. Meaning, like, what kind of mathematics did you do? What kind of statistics did you do? How did you apply the physical principles? That kind of thing. Anything that came from the data goes in the results. So that's pretty much what the body is. Another very lengthy section of the paper, depending on how the study is constructed. It might be much longer than the introduction, or it might be about the same length. The last section of the paper is the conclusion. So you've gone through the details of the background in the introduction, you talked about the methods, what kind of data you took, and you talked about the analysis and what the results were. And so now what your reader wants is a high-level interpretation of the entire work. High level means it doesn't necessarily have to be that detailed. It could be sort of discussing in context with what happened in the introduction, what your results were they good, were they bad, did it prove the thing you're expecting it to prove, that kind of thing. It can be detailed. You can go into the very fine detail analyses about what happened with the data, but typically that happens in the analysis section right before the conclusion. The conclusion is usually more for less detailed, more conceptual ideas about what happened in the work. So typically you don't want to just summarize the work again. If somebody wants to know what the work was, they can go back and read the entire thing that you just wrote. You want something new in the conclusion. You want important outcomes and what the next steps are. Now, occasionally you want to end the conclusion with some kind of very strong statement about how important the work was. Basically, it's like summing up your argument to somebody. You just spent a few pages describing all the things you did. Now's your chance to have one or two sentences that really summarizes how great the entire thing you did was. Some people put those in their conclusion, some people don't, but this is roughly what the conclusion includes. Now, in this class, we will not really be doing this style of conclusion. You can actually start your conclusions with a paragraph or so that kind of covers this stuff if you'd like. Actually, in our conclusions, what we'll be doing instead is answering specific questions about the lab. And those questions will be given to you in the actual lab manual, in the procedures. The reason is that actually this is a very difficult process to do. How are you supposed to tell how important the calculation of the gravitational constant is, or how important the ratio of the electronic charge to mass is? Those are obviously very important things, but they're also not new things. We are rediscovering these things for ourselves to make sure that we understand how they were done, but we're not actually going to be doing anything new in the lab. That's not the point of this class. So it's going to be a little bit difficult to come up with this kind of really solid conclusion about the lab reports that we're going to write. So you'll just be answering questions, which will sort of get at some of the issues in here and hopefully round out the papers very nicely by answering the questions about the work that you just did. Okay, so that's a summary of not only the scientific paper, like generally, like these 4 sections work pretty well for how do you write a scientific paper, but specifically for our lab class, these are the 4 sections we'll use. Our conclusions will be a little bit modified in this way, but other than that, you'll essentially be mimicking the idea of writing a peer-reviewed journal article. I think that's it. Thank you for watching this video. I hope it has been clarifying, and I will see you in class.